In our next talk on application architecture, Mel Canner, one of our senior systems teachers at Microsoft University, will be showing you the internal architecture of a presentation manager application by taking a detailed look at a program written in C specifically for this purpose. The complete listing of the sample program he'll be using is provided at the end of his presentation in your conference notebooks.
Yesterday, Manny Vellon demonstrated the Windows Presentation Manager user interface. This morning, John Pollock introduced you to the Presentation Manager programming model. In this talk, we will implement a portion of that model in code. So we're going to look at how we go ahead and program a typical, simple Presentation Manager application. All right. For those of you who are already familiar with programming in Windows, this material will not be exceptionally new. The only thing that will be new for you will be that you will be able to see some differences between between the Windows Presentation Manager model and the Windows 2.0 model. So there are some minor differences that will be you'll be able to see from this application, but the majority of the information is essentially the same. Okay? So let's look at what we're going to talk about. Is first I'll go over and talk about the Presentation Manager, some of the services and the style of the programming, and then we will go, the majority of the time will be spent constructing the actual application. Then we'll spend a little bit of time looking at some programming considerations that are necessary for you to be aware of while you're programming your application. All right. So let's look at where a Presentation Manager program fits in to the environment into OS2. As you can see from this slide, that the applications sit on top of OS2. The Presentation Manager is a portion of the operating system. There are some applications that call the operating system directly, or call the kernel portion of the operating system directly. Most of the applications will be concerned primarily with making calls on the Presentation Manager itself and not making calls directly to the kernel portion of the operating system. All right. At this point, let's look at how an application works within the environment that is provided for us. So I'm going to switch over here and look. We're going to look at an actual demonstration. If you will notice that on your screen, I have a program called Calculator that is sitting up in a window on the screen. Notice that I have a little arrow that represents the cursor on the screen, and I am moving the mouse around, and the arrow is following the movements of the mouse. Notice as I traverse over the material over on the left-hand side, over the text that is sitting over there, the text gets obliterated or written over by the cursor, by the arrow. And as I move the arrow across the text reappears underneath the arrow as the thing moves. What is happening there is that the screen is being redrawn as I move the cursor, and this is this material, or this effect is being provided for you by the services of the system. In fact, in this particular case, it's the mouse driver that is providing those services. But this is not something that you yourself as an applications programmer have to program. Notice also as the cursor moves up into inside the calculator area that the cursor changes its shape, and that it has become a small octagon, and that as I move outside of the calculator, it changes back into an arrow. The changing of the shape is something that you as the programmer take care of. The actual redrawing of it on the screen is being provided for you as a service by the system, by the environment in which your application runs. Notice also now as I move the cursor up and point to the edit item on the menu bar and then press the key, I get a menu that pops down in which I have choices to choose from. Right? And that menu, the popping down of the menu, is a service that is provided for you by the environment. You don't have to program that. What you have to program is to tell the system what that menu should look like. What are the items that will be displayed when the menu pops down? But you don't have to actually program the popping down of the menu. That's provided for you by the system if your application takes advantage of those services that are there. All right. So there are a set of services that are provided for you within the system. These are pre-programmed, and you can take advantage of them. If you follow a particular form or style of programming, then there is a wide variety of functions and services that are available for you. Your program then essentially consists of making the appropriate calls to the functions or services that are available within the system and responding to messages that the environment, the system, will be sending to your application. And we'll look at that point a little bit more closely in a minute. All right, so at this point, let's switch off the demonstration and move back to the slides. In summary, a presentation manager application can have a certain form or style to it, and if you program within that form or style, then there is a great number of services that are provided for you by the system. That form or style, as you've seen on the screen, is the shape of the window with its frame around it. It has a title. It has a system menu that sits up in the corner. That's the one that looks like a little toaster, one-slot toaster. Then it has a standard menu. It has horizontal scroll bars and vertical scroll bars on that. If you program within that framework, within that style, then there is a great number of functions and services that are provided for you by the Windows Presentation Manager environment. Let's look at with a little bit more detail at some of the items or types of services that are provided for you by the environment. The menus, for example, which we've already seen, when menus are the items that you can click on, and down pops a menu that provides you with some choices for selection. Dialog boxes are methods for the environment to, or the system to communicate with the user. Icons are pictures that can be used to represent a running application. The cursors you've already seen. You can, they move around on the screen in response to the mouse. You can change the picture that is used as the cursor. We have a wide variety of graphics capability for drawing lines and text and circles and ellipses. This information will go into much more detail later on. There's a whole section just on graphics alone. We have windows, frameworks for the windows, predefined classes that you can use within your application. User messages, the mouse input that we have indicated. As the mouse moves around on the screen, you'll get a representation with the cursor, but it also responds to the clicks and the position of it on the screen. We have message queues, and I'll go into that in more detail. This is the method that the system, the Windows Presentation Manager system, uses to communicate with your application. And we'll look at that. And then in addition, since Windows can be moved around on the screen, there's a certain degree of window management that is available within the system. So at this point, let's go look at actually constructing an application and looking at the code for a relatively simple application. So what we're going to do in we're going to build a main program, and then inside that we will create a window. Later on, then we will modify a menu and add a dialog box. But before we can do all of that, to look at some of the code, we need to briefly review some of the naming conventions that we use within the code. So our naming conventions that you will see in the code that follows, all the constants and the macros are in all caps. These are predefined or user-defined macros or constants. Most of our functions have a leading capital to distinguish them from variable names. The presentation manager functions that we will be calling, most of them are have a leading WIN or prefixed with a WIN. For variables and type definitions, we have a few standard conventions. We have a prefix that is usually used to, in lowercase, to indicate the type of the item that we're looking at. So for example, LP, if you see LP as part of a variable name, as a prefix on a variable name, that means that it is a long pointer or far pointer. B's are bytes, F's are booleans or flags. So on the, as an example of taking these prefixes and combining them together, looking down on at about 2/3 of the way down, you'll see LPSZ. This stands for a long pointer or far pointer to a zero-terminated string. And following that would be then the name of the variable, or to represent what it actually is. So at this point, now let's start looking at the code. So we're going to build an example application, which I've called example app, and it will have in it some include files. We'll need some global variables. There will be the main function, and then there will be a window procedure that will correspond with the window that will handle the operations for the window that we're going to be creating in there. Let's look at the include files. The include files, there's win.h, which is provided for you in the system. Win.h has predefined constants and macros that are used and function definitions that are used by the Windows environment, by the Windows system, the presentation manager system. If you have any constants, macros, type definitions of your own, then you can include them in your own header file. All right, at this point, then let's go look at the globals variables. We're going to need a couple of strings. One of them will be a string to indicate what the class of the window is that I'm going to be building. We'll look at that, where that's used in a moment. We're going to need a title that will show up on the title bar of the window that we will create for it. And then we'll need some handles to different portions that will allow us to keep track of certain things within the system. So the first one is the HAB, is a handle to an anchor block. An anchor block is a information within the system that the presentation manager system uses to keep track of information about the application's environment. We're going to build a message queue for handling messages that are going to be sent to the application, and so we'll need a handle to that. We will build a couple of windows. One of them is going to be the client window where we're going to be doing our drawing and doing our work, and another one is going to be a frame around it that will contain the scroll bars and the menu and the system menu and so on. So we'll need handles to those. We will also need to be able to get at the messages that are going to be in the queue, so we'll need a variable to get at that. All right, at this point then, let's go look at the main function. Right? So the main function looks like any other standard C function that's going to have 4 parts. There will be, like any other program, it is going to be there's going to be an initialized part, and then at the bottom there's going to be a finalized part. And in between, then we will create a window, and then we will process some messages. Right. Notice that up on the top line, we have a piece of a keyword called cdecl, C-D-E-C-L. This indicates that we are going to use C calling conventions when in this main program. So let me stop for a minute and point out that within Windows Presentation Manager applications and within OS2 applications, there are two calling conventions available that we may use. One is called the C calling conventions, one is called the Pascal calling conventions. Essentially, it has to do with which function passes the parameters and in the order in which the parameters are passed. For example, in C calling conventions, parameters are passed from right to left, and in Pascal calling conventions, the parameters are passed from left to right. Another aspect of it is which function takes care of restoring the stack to its original condition after the function is exited. In the Pascal calling conventions, it is the callee, in other words, the called program that takes care of restoring the stack. In C calling conventions, it's the calling program that takes care of the stack. We use both conventions within the system, but primarily the Pascal calling conventions. In those particular cases where we need the C calling conventions, then it is preferable to specify directly that we're going to be using C declarations with the cdecl keyword in the function header, for the main function header. All right, let's look at the initialization code. All right. Initialization is relatively simple. We just need to call the Windows Presentation Manager system and let it know that the application is here and that it's ready to work. The Windows system will do its internal housekeeping and keep track of the application and return us a handle to an anchor block, which we will then use. Right? The next thing that we're going to need is we're going to need a message queue. The system is going to be sending us messages in response to window clicks in the window, in response to the mouse clicks, in response to the keyboards, and in response to the user selecting something from a menu. The system will trap those and send us a message indicating that this event has occurred. We need a queue in order to store those messages. So we make a call to WinCreate message queue, passing it our handle to our anchor block, and it creates a queue for us. The next thing that we would do in line here is to create a window. However, before we do that, let's just look at the counterpart to the initialization, and let's look at how we would clean up and exit the program when we're done. So we will create a queue and create a window, and I'll show you that in a little while. We'll leave that to the last item that we do. But since we're going to create one, when we finish, we should destroy that window. So we make a call to win_destroy_window. And since we're going to then be through with the queue, at that point, we should destroy the queue, the message queue, and when we're all done, then we should call the system again to say that it can remove us from its list of applications that it's running. So we make a call to win_finalize. Right? So we have initialization, we have the finalization. The second thing in line will be creating the window. Let's look first at how we handle the messages that we're going to be getting. All right, so to handle the messages, what we need to do is create a loop that makes calls to win_get_message, which gets the next message out of the queue, if there is one. And then once we have gotten that message, then we can do something with it. We may have some code in there to look at it. We may have some code to do some translation of some keys in there. But eventually what we want to do is we want to take that message and we want to dispatch it. We want to send it to the procedure that will do the handling of the message. That will be our window proc, and we'll look at where that comes in after we have created the window. So in this message loop, we get a message off of the queue, and then we send it on its way to the appropriate place. We may look at it in between if we needed to. This loop will continue as long as there are messages for us. Actually, this loop will continue until we get a message that says quit. A quit message, when it sends us a quit message, it also returns false, and that will get us out of the while loop, and then we would go on to clean up. If there is no message in the queue at all, then we don't return from the call to win get message until we have gotten until there is a message in the queue. If that message is a quit message, that will get us out of the loop. So this loop, this place in our code, is where we sit and process messages one after another, picking them out of the queue until we get a quit message, and then we terminate our program. So at this point, let's go look at creating a window. So we're going to create a window with a title bar and some scroll bars and so on, and in it we will have an area that we are going to be doing some drawing. And that particular area we refer to as the client window. That window the system doesn't know about yet, so what we're going to do is we're going to describe it to the system. Essentially what we're doing is we're going to create a class of windows that we're going to use, and we're going to use one of them, create an instance of that class for our client window. So the first thing we have to do is we have to register the class. So we call the Windows Presentation Manager saying register a class of windows, and I'm going to give it the name of example app class, right? And I'm going to tell it the name of the procedure that is going to do the processing of the messages for that window. Right? And then I give it some information about what it's going to look like. What are some of its style characteristics? And in this particular simple example, I've only given it one style called WS Size Redraw, which means that it can be redrawn and resized when it gets a message to do that. All right? So we're going to create a class of windows called example app class, right? And it's related with that is there is a window procedure or window proc, we usually refer to it, that is going to process the messages for that kind of a window. Right? Then the next thing that we're going to do is we want to create a frame that has a title bar and the minimum and maximum buttons on it and a border around it that can handle resizing. It's going to have a system menu and then a regular menu. It's going to have a vertical scroll bar and a horizontal scroll bar. Right? And I want that window to be a framework that will also include a client window in which I can do my drawing. And this mechanism is relatively standard. So we have a predefined procedure or function available within the Windows Presentation Manager system that will create a standard window like this for you. So we call WinCreate Standard Window. It creates a frame. We pass it information as to what we want it to look like and what are the things that the style of it and what are the items that we want to include in that style. In this case, we want to make it visible. We want it to be able to be seen. We want a title bar and the min-max buttons and so on. Right? We also pass it, if you look on the next slide, we pass it the client window. This is the class of the client window. We pass it the title. That's the string that had the title in it. And that's what will get displayed as the title. We tell it that the client is going to be visible. We pass it a menu that will be displayed along with it. And then we pass a handle to the client window itself. All right? at the end of this call, what has happened is that the window has been created, but it hasn't been displayed yet. The first thing that the system is going to be doing at this point is going to be sending out a series of messages to our application related to that window. Those messages are going to be things like create the window, and then eventually to paint it or display it on the screen. So we then need a place then to handle and respond to those messages that we're going to be getting for the window. So we've created a queue. Those messages are going to be coming to a queue, and we're going to be picking them out of the queue with WinGetMessage. We're going to be then transmitting them to the window proc. And the window proc that we said we were going to be using for it is example app window proc. That was the one that we registered with the class of Windows when we registered the client window. Right, so we create a procedure that is called example app window proc, and the parameters on that are essentially messages that are going to be coming in. The window proc consists of a switch statement that switches on the messages that come in, and then we will do things and have case statements that respond to the particular messages that we will expect to get and need to do something with. Notice that in the procedure header at the top, we have var Pascal as keywords in there. This indicates that we are using Pascal calling conventions for this procedure or this function, and that it's a var call to this function. All window procs must be var Pascal. We expect that when the Windows system, Presentation Manager system, calls the window proc, then it's going to be using Pascal conventions, and it's going to be a var call. All right? So within the switch statement, within the case statement, one of the messages that we're going to get is a window message wm create, and at that point we may do any window initialization that would be necessary. We expect sometimes to be getting WN command messages. These are the messages that would be coming to us when somebody selects something off of a menu. And we will, as I mentioned, we will be getting WM paint messages. These are messages that we will get whenever it is time for us to repaint the window on the screen, to update the painting of the window on the screen. Right? Any messages that we don't want to process, we can then send to a predefined window proc called WinDef window proc, which is the default. It has predefined capabilities for us, and for example, we might get messages called a WM sys command. These are the ones that would be coming from the system menu. Size and move commands are normally up in there. We don't want to do anything special about that within our application, so we will just pass those along to WinDef window proc and let it take care of the WM sys command messages. Right. So we need to add a couple of things to WM Paint to do the actual painting. But once we added those, if we did that, then at this point the painting would take place and we would see the following on the screen. Our application has a title called Example Application. It has a horizontal scroll bar. It has a vertical scroll bar because we told it to do so. It has a frame around it that is movable and sizable. It has a menu on it, and we'll talk later about how it got the menu information. And it has a system menu up in the upper left-hand corner. Those were the characteristics that we told it to create. So it created a frame, and it created a client area within that frame. That is the area that we're going to be doing our drawing. Right? Now, what could we possibly do within that drawing? Let's look at some possible response to the paint message. So I've added some code in here in the window proc for the case of WM Paint. Right? And the two things that we need in there is the first thing is we need a begin paint message or begin paint call to start the painting process. And then when we're finished at the bottom, we notice we have a wind end paint call which stops the painting procedure. And then in between, we can do and take advantage of drawing and capabilities that we have available to us. So one of the things I want to do is I want to draw some text in the window, in the client window, in the upper left-hand corner of it. And so one of the ways that I can do that is to first find the size and shape of the rectangle that is the client window. And I can do that by a call to winGetWindowRectangle. And it'll return me a rectangle which will have the description of the coordinates of the rectangle. Actually, the upper left corner and the bottom right corner will be in that structure. Right? And then using that, I can find the upper left and the upper top, and I'm going to paint or draw some text at that point. So I make a call to winDrawText, passing it the text that I want to draw and where I want to draw it in the rectangle. Using the information from the rectangle, I say do it at the upper left and the upper top. And if I did that, then this is what it would look like. So notice we now have the word hello written in the upper left-hand corner of the client area. Right? Okay, so at this point, then, let's go over what we have done. We talked a little bit about the environment within an application that an application fits in. We talked some about the naming conventions that we use within the code, and then we built a main program that had some initialization and some finalization. We created a window within that main program, and we created a message loop that handled the processing of the message that was coming to the application. Those messages then were transmitted back through the system, through the Windows Presentation Manager system, and were sent directly to the window proc, which then processed the messages that for that window. Okay, so at this point, we have a simple application that doesn't do very much. Let's look at what we might be able to do to it and some of the features that are available that allow us a little bit more sophistication. So one of the things that we typically do with an application as part of a style thing is we like to provide in the application a place where the user can get some information about the application. For example, a place where he can click on a menu item and what would be presented to him would be a small piece of dialogue that would tell him perhaps the copyright date, who created it, and what company created the program. Right? We usually refer to as adding an about box. So what we're going to do in this is we're going to add to the system menu another menu item called about. Right? So the system menu looks like this. If you drop down the system menu right now, it looks like this. What we want to do is at the tail end of this system menu, we want to add a new item called about. And then, so that would look like that, right, on the screen. Right? So we've added the word about onto the menu that has been popped down. The user then can click or select the about, and in response to that, he will get a dialog box that would pop up in the middle of the screen. So a box that would give him some information. In this case, it tells him the name of the application and the copyright date and the version number. When he's finished looking at that, he will click in the OK button on there, and the dialog box will dissolve, and we will go back to the ready to accept anything else, to do the rest normal work within the application. All right? So what we're going to do is we're going to add to the system menu the word about on the end of the menu. We're going to add an item to the menu. And then in response to that item on the menu, we're going to put up a dialog box. And then the user will be able to read the dialog box, and then when he's done with it, be able to click on the OK, and the dialog box will dissolve. That is what we want to modify our application to do. So there's 4 parts, essentially, to doing this, and what we have to do within our application. The first part is we need to add the item to the menu. So we're going to go to the system menu, we're going to add the item. So we're going to write a piece of code that will do that. Right? The next thing that we need to add is we need to add code that is going to respond to the message that we're going to get when the user clicks on that item, that new item that's in that system menu. Then when he clicks on the word about in the menu, a message is going to be sent to our application, and what our application has to do in response to that is to put up a dialog box. Right? So we'll add that code. Right? Related to that, there's a piece of information as to what does that dialog box look like. We have to describe to the system how to put what that dialog box should be like when it is presented on the screen. And then the final thing is that the user is going to click on the OK button in the dialog box, and then we need to respond to that message. When he does that, he clicks on that OK, a message is going to be sent again to our system, right? And we will, that message then will end up in the appropriate code that will respond to that message, and what we want it to do would be to dissolve the box. And then return back to where it was before, so that we can continue doing normal work. All right, so there's 4 parts. Let's first look at how we go about inserting the piece of code onto the system menu. All right, so we're going to, right after we create the window, we're going to insert the code that is going to be the string about into the system menu. So it's going to go here after we've created the window, before we've processed the messages. And here's what the code would look like. Right? So the first thing we need to do is we need to describe the menu item that we're going to add. All right? So we have a predefined structure called a menu item. And in it has some information about the menu item that we're going to add. The first item on there is this position, and we can specify where in the menu the item should be. And in this case, what we wanted is to be the last, after the last item. So we have a special code for that, which is in this case -1, to indicate that it comes after the last item in the menu. The next thing that we want is we want to describe some style information about it. And one of the things that this is that it's a string. We have other choices. We could put icons up there and have pictures displayed within the menu. But in this case, we're going to put in the string. The string that we're going to be putting in is the word about ... And the other item in the style is that when the person clicks on this item in the menu, we want a system command message to be sent to the application. All right, so the MIS sys command is the other piece of style information that indicates that. And then we have the next thing is an ID that uniquely defines the item. As another, when you send us the sys command message, send us some sort of number, a unique number that will describe which one of the sys command items has been clicked. Okay, because there's other things that are on the menu. And then for more sophisticated applications, we have a couple other fields within that structure. All right, so once we've created that structure, that describes the item in the menu. Now the next thing that we want to do is we need to find the system menu. The system menu, that little box that looks like a one-slot toaster that's up in the upper left-hand corner of your screen, of the application, is a window itself. And as a matter of fact, all of the items within the frame are windows within a larger window. You can think of them as sub-windows or child windows. When we created that frame, we created all of the parts, and we created all of these sub-windows or child windows, and we can delineate them by name. The system menu has the name FID sysmenu, or that index to refer to it, and I can go get a handle to the window that is the system menu by a call to win window from ID, using the ID for the system menu, using the handle to the frame that I created. I make this call and I get back a handle to the system menu. Once I have the handle to the system menu, since that system menu is a window itself, then all I have to do is send it a message. I send it a message that says, insert this menu item, pointing to that structure that I had just created. Insert this menu item into the menu. Right? And here's what it should look like. Insert the string about ... using the information in the structure that I created, insert this into the menu. It's just as simple as that, just making one call, win, send message. All right? Once we've done that, we have now added, this is all we need now to add the line about as an item on that menu. Right? Now we need to add the code that is going to respond, that will handle the message that will now come from the system when the user clicks on the About selection within the menu. Right? So we need to add, within our window proc, where we're switching on the messages, we need to add a response to the wmsys command, because we're going to get a wmsys command message, and we're only interested in the one sys command message, the one that's related to the about. Okay. So when we get the number in the message that for a sys command that says this is the about message that was clicked on, what I want to do in this case is create a dialog box. And all I have to do that is make a call to win dialog box, win DLG box, and I pass it a handle, right? And then I pass it a procedure, a window proc, that is going to handle the messages from the dialog box. The dialog box itself is a window, right? And whenever I create a window, I need a window proc that handles the messages that I'm going to get from that window. Right? So I call win dialog box. I hand it the name of a procedure that is going to handle the messages, and then I describe with the IDD about dialog, about DLG, I describe to it what that dialog box is going to be like. All right? That dialog box definition you create in a resource file, a resource script file, and we'll look at that in more detail in my next talk on the actual mechanics of constructing an application. But that dialog box definition will look something like this. Right? It's a template that describes the structure of the dialog box. That it has a frame, and it has some text in it, and it has an icon, and what this text looked like, and it's got a push button, and where this information should be displayed within the dialog box window. Right? So to create the dialog box, we make a call to win dialog box, and we pass it the description of the dialog box, which we created in a resource script file, and then we just refer to it by name or by number. We then, at this point, then the system will create the dialog box and put that window up on the screen, and that would look again like this. Right? So at the end of that code, in response to the Win dialog box call, we will get this dialog box on the screen. Right? At this point, the user in this one can only do one thing, and that's to click on the OK button. When he clicks on the OK button, a message is going to be sent. Actually, a WM command message is going to be sent in response to that. And we now have to have a place that is going to respond and handle that particular message. Right? So where that message is going to end up is in the window proc for this window, the dialog box window. And that procedure we called about DLG proc. That was the name of the procedure that we passed to Win dialog box when we created the dialog box. Right? And in there, we're going to get messages, just like any other window proc. Again, it has a var Pascal in the header. And we switch on the messages that come in. And the messages that we're looking for, the only one that we are looking for is a WN command message. And in response to that WN command message, what we want to do is we want to dissolve the dialog box. So we call Win dismiss dialog. And that will dissolve the box. Anything else, any other messages that might come in, we have a default dialog procedure to handle those. Right? So in review, right, what we did is we built an application, a main program. It had initialization code in there. And we told the system that we were here, and we built a message loop. We built a message queue. And then when we finished on the finalization part, we destroyed any windows that we created, and we destroyed the message queue that we created, and then we told the system we were no longer here. In between, we created a message processing loop that picks the messages off of the queue and sends them to the appropriate place. Prior to that, we created a window. In the code, we created a window and then a window proc to handle the messages for that window. Right? And then in addition, we modified a menu. We modified specifically the system menu by adding an about item. And then we added code to respond to the user clicking on that new item in the menu. Right? And we put up a dialog box. And then we added code to respond to the clicking of the OK within the dialog box to dissolve the dialog box. Okay, now that we know the fundamentals of building a Windows Presentation Manager application, let's look at some of the things that you need to take into consideration when you are designing your application. These things are the fact that we have capabilities now for multiple processes and multiple threads. And related to those, then there are some things that occur that we need to take into account. For example, with multiple processes and threads, your code is reentrant, and that reentrancy must be considered. Serialization is one of the ways of looking at that or solving the reentrancy problem that may occur. In addition, there's one small caveat, or one of the things you need to be aware of, that at the current state, we need to, when building dynamic link libraries, if you're going to have part of your application in a dynamic link library, we need to be aware of the SS equal DS as part of the C runtime library. I'll talk about that more in a minute. All right, let's look first at multiple processes. So multiple processes, a process essentially is a program. Or it is an instance, a running of the program. So within a Windows application, we can start another program running. We can start a different program, and an example of that would be, so if your application were a word processor and you got to the point in the user has selected that it's time to print, The print requires that a spooler be running. Your application could start the spooler if it hadn't already been started. So this is an example of one program starting another program, or a process starting a completely separate process. All right? An example of a one process starting the same process is perhaps in a word processor, if you wanted to work on another file, in addition to the one that you're working on now, instead of having special code in there that allows two files to be open at the same time from within the word processors, as most word processors do now, you might just start another copy of the word processor of the original code. Actually, there wouldn't be another copy, but there would be another process running, since in OS2, the actual code would be shared between the two processes, between the two copies running. There wouldn't be a duplication of the code within the system. This presents some problems that you need to consider, and that's the reentrancy problem, which we'll look at in a minute. So another aspect would be is the multiple threads aspect. So multiple threads is where you have another portion of your program in response to some user action that starts and as a separate coroutine. So for example, if you were running a spreadsheet, and in the spreadsheet, the user decides it's time to do a recalculation, chooses recalc from one of the menu items, and clicks on that menu item, and message gets sent to the application, to the spreadsheet application. The message gets dispatched to the appropriate window proc for that, and then in response to that message, we can start the recalc code. Now, normally, what would happen at this point, if it's a fairly large spreadsheet and there's a lot of formulas in there, the recalculation could take a long time, and the system would sit and wait. You wouldn't be able to do anything else while that recalculation was going on. If you start another thread at that point to do the recalculation, then the main thread then returns back to the message loop and can process new messages. So for example, one of the things that you might want to do after the recalculation is done would be to print it. Right? So if the recalculation was in a separate thread, then the main thread would return back to the main message loop, and the user then would be able to click, say, the print and the print option. One of the print options in there might be to do the setup for the printing, like choosing the page size, choosing the page arrangement and the margins, and so on. Those items could be going on concurrently with the recalculation. Now, so having the two separate threads then allows you to process other messages concurrently with the recalculation going on, instead of having the user have to sit and wait for the recalculation to be done before he goes on doing anything else. This then presents some difficulties. Although this is a great feature, there's other things now that you have to take into consideration when you are working with these kinds of things within your program. And one of those is that your code is reentrant. Right? So you have two versions or two spreadsheets going at the same time, or two word processors going at the same time. The code is reentrant, and you have to be careful about shared data that is being used by both processes at the same time. You must take care of this. One way of handling this is to use serialization. Essentially, you block in serialization. You block the use of the shared data while one process, you block the other process while one process is running. Right? Another example of the serialization involved in there is that the print operation that you started with a second thread. Right? You have the thread going for the recalc, and the person chose the print setup, chose print, and then the setup. When he's finished with the setup, one of the things he would want to do would be to print, but it would not be appropriate for him to print before the recalc is done. So you need to have a mechanism in there, a serialization mechanism in there in order to be able to handle a wait, essentially, for the recalc to be done before the actual printing can be started. Right? One of the ways of handling that within the Windows Presentation Manager system is essentially to turn the menu item that does the actual printing, just turn it off. And the last item is a caveat. When you are building dynamic link libraries, and we'll talk more about the actual mechanisms for building a dynamic link library, then in those cases you need SS not equal to DS, because the stack that is used within a dynamic link library is the stack of the caller, right? Rather than the stack, rather than the data segment of the library itself. So the problem that occurs is that currently within some pieces of C runtime make some assumptions about SS being equal to DS. A few of the routines like printf and scanf make these assumptions, and you must be aware of these, which ones of these routines are make these assumptions. These are documented in the C runtime document, and just be aware that there are pieces when you're creating dynamic link libraries, there are some pieces of runtime that you must avoid because of the SS equal to DS problems. This item's been mentioned before, and solving this or changing this for future releases is being considered. But at the present time, when you are creating your applications, you must be aware of these. Right. In summary, what we've looked at in this talk, right, is we've looked at the Windows Presentation Manager environment and the services that it provides for us and the style that is expected for our particular application. And then we looked at actually creating a Windows Presentation Manager application. We looked at the code to put together the pieces. And we talked briefly about some considerations that you must keep in mind when you are constructing your application. Thank you.
For additional information on the topic we just covered, be sure to take a look at the written questions and answers that accompanied this videotape.